Hello everyone, it's 10 o'clock sharp here in the Netherlands, so we're going to start with today's webinar. Welcome. My name is Eric Nijveld, co-founder and CEO of technologycatalog.com, the leading technology platform for the energy transition. In November last year, we announced the winners of the Tech for the Energy Transition Awards 2021. And our motivation for organizing these awards was to highlight the role of technology in achieving net zero. There were 5 award categories, and in today's webinar, we give the 5 winners, as well as the other 10 finalists, the opportunity to pitch their technology. And by the way, for those who didn't make it to the finals last year, we're going to organize another award competition this year, and more details will be announced sometime in the middle of this year. Before I move to the first category, few practicalities. For each category, we will first do the pitches of the finalists with 6 minutes per company. This is then followed by a brief Q&A session. And if you have any questions, you can type them in the Q&A box that you see on your left-hand side. And in case there's not enough time to address your question, then I would like to encourage you to contact the supplier directly. And an easy way to do that is to go to the technology page on technologycatalog.com and to type in your question via the contact form. The webinar will be recorded and you will receive a link after the webinar, and feel free to share the link with your colleagues. We will now start with the first category, carbon capture, utilization and storage. CCUS is an important element in the scenarios to limit global warming, and therefore it was one of the award categories. So with that, I would like to hand over to the winner of this category, Carbonate Systems, a company based in the UK. And I would like to hand over to Selina as the presenter. Selina, over to you.
Thank you, Eric, and thank you for the introduction and having us today. We are Carbonate Systems, and with that, accelerated carbonation technology. We're a circular CCUS company that help the hard-to-abate sectors reduce their emissions, but also address the sustainable use of the residues that they produce. In the process, also helping them manufacture low-carbon building materials so that they can use. Next slide, please. And this is how we see the issue, the linearity of traditional value chains within the hard-to-abate sectors. And when I speak about hard-to-abate sectors, we mean the cement industry, steelworks, energy from waste, paper and pulp, etc. And specifically, even the cement industry alone accounts for 8% of global CO2 emissions. So the scale of the problem is well known. And we attribute some of this to this linear model. Take, make, use, dispose as a system directly leads to emissions, residual waste, and of course also the expense associated with both of those. We see this with our clients as an environmental, but also as an economic burden. Next slide, please. And this is where we come in, and we like to think of ourselves as part of this solution. We help enable the circular model as well as the closed loop system and help our clients transition to that. And we see this because we help address and use the carbon emissions that our clients emit and use that to treat the residues that they also produce in their manufacturing processes. And the output of that are these 3 key positive assets. Firstly, looking at the direct cost saving opportunity. And if we could go back, please. Thank you. Looking at the direct cost saving as attributed to diverting the landfill residues. Secondly, in the process, actually manufacturing low carbon building materials that they can either use directly in their processes or sell on as an additional revenue stream. And lastly, of course, by doing this, we help them decarbonize their production as well as moving towards a more sustainable business. Next slide. And we do this through our technology, accelerated carbonation technology. As the name already suggests, this is based on the natural process of carbonation. This is one of nature's ways of naturally sequestering CO2. And what 20 years of research and development has given us so far is that we're able to control, manage, and accelerate that exact process. Now, how does this relate to the hard-to-abate industries? Well, the residues that they actually produce in their processes are naturally reactive with CO2. And this is because they contain calcium and magnesium compounds. Through this, we're actually able to manufacture what we see on the right-hand side here. This is an image of aggregate. This is a low carbon alternative to the natural coring of aggregate. And because of this, again, directly enabling the circular economy. Next slide, please. And this is when I get to introduce all of you to our CO2 container, the containerized system, effectively a modular and mobile CCUS solution that can be directly deployed to our client sites. And what we also like to term carbon capture in a box. Because as you can see in this image here, our technology can effectively be housed within 2 shipping containers and deployed anywhere in the world. And this image particularly was actually taken by our first commercial client, the VCAC Group. It's a cement plant in Montpellier in France. And as we can see here, there's the direct capture of CO2 from the flue stack on the top right-hand side of the container, and also the input of residues from a silo. And at the very left-hand side, we see a conveyor belt, and that's where the aggregate is actually already transported out of the system, and in this case, directly onto a truck. And like I mentioned, this can be directly used by our clients on site in their existing production or sold on. Effectively, the CO2 container enables seamless integration of a CCUS system into an existing plant. So it really is a real and ready solution today. And just to summarize, so Carbonate Systems with its technology delivers economic sustainability today through offering our clients an opportunity of direct cost savings, a reduction of their carbon footprint, but also manufacturing low carbon, sustainable building materials as an alternative. And these aggregates can be used in things like concrete blocks, road filler, cement plants, etc. So there is direct application and use for them. And please, if you have any questions at all, please don't hesitate to reach out to me directly or my colleagues by scanning the QR code or jotting down my email address. I look forward to hearing from all of you, and thank you for your time.
Thank you very much, Selina, for this presentation. Very insightful. And indeed, if anyone in the audience has a question to Selina, please type the question in the Q&A box. And after we're finished with all 3 presentations in this category, we'll have a Q&A session. With that, I would like to go to the second presentation, all the way from Australia, from Amir, Aryana, from CSIRO. Over to you, Amir.
Okay.
Over to you, Amir.
Let's blame that on the user issue. But thank you, Eric, for the introduction, and sorry everyone for that little mini glitch. And thank you, Technology Catalog, for providing us with the opportunity to present our tech today. CSIRO stands for basically the Commonwealth Scientific and Industrial Research Organization here in Australia. We comprise of 5,500 people with an annual budget of $1.2 billion a year. We've worked on basically a technology that allows us to basically capture CO2 really readily and cheaply. And this is based on a 2-part mixture, which is we refer to as liquid amine particles. Next slide, please. So basically, in a nutshell, we've identified a 2 chemical component system, which is commercially and readily available in the marketplace at the moment, being used for different sectors and different industries, that when combined together and synthesized, have shown a very high affinity to CO2 capture, either from direct air or from post-combustion capture, which we refer to as inline systems. We have demonstrated our unit for direct air capture, and we focused our priority on direct air capture by demonstrating our unit for a period of 6 months on capturing a 5 ton per year system. And if I can just give you an image in terms of what the unit size looks like, it's basically a desktop computer, you know, the good old ones that you have underneath your table. That's the size of the unit which captures the 5 ton per year system. I will go into how we are scaling up and where we are at later on, but these are some of the, I don't need to read what's on the slide, but we got a number of advantages and so forth. So let's get into how the system actually works. Next slide, please. So unlike conventional liquid amines, where it's a liquid system and they have a low surface contact area with CO2 and therefore the CO2 loading, our system basically combines a solid and a liquid and creating that wiggly structure that you see in the middle of on the right-hand side that increases the surface area and capture. Think of it as a snowflake underneath a microscope, right? By which it has the tentacles to basically absorb a lot more CO2 molecules and therefore gives us basically a lower footprint compared to other technologies. Apart from that, we also can rejuvenate our system at much lower temperatures. And that gives us a very lower operating temperature or energy release that is required for rejuvenation cycles. And if you want to know what it looks like, it basically looks like that fine powder that you can see at the bottom of the screen below. Next slide, please. So, in essence, it's our DAC unit, our direct air capture unit, is basically a glorified oven. That's what I like to refer it to as a glorified oven with 2 fans in front of it. And there's a reason why it has 2 fans and not one big fan. And I can definitely disclose all of that at a later stage, but let's just get into it. So it's basically 2-fan system. There's a number of trays within the unit. So if you can look at the top left, we basically flow air using the fans at high rates over a set of trays. Think of them as pizza trays in your oven, your household oven, which encapsulate the chemical. These have a high affinity to CO2 and capture the CO2 readily. Once the CO2 is captured, and that's approximately a 30-minute period. Now, the unit that you're looking at here is a 0.25 tons per day. We shut the inlet and outlet and basically activate, we activate our basically vacuum system, which gets rid of the residual air, which gives us very high quality and high concentration CO2 once we activate at the very bottom, basically our heating system, which releases the CO2 and is captured elsewhere. The diagrams on the right basically depict the system and the tray system design and so forth. Next slide, please. Our inline system is basically a set of, these are the industrial units. So these are the inline systems for post-combustion capture. Basically, they're a set of chambers that are pre-filled with the chemicals. So these ones, unlike the DAC system where the air flows over the top, these ones, the flue gas flows through each chamber, which is pre-packed with the chemical, the LAP, liquid amine particles. And if you can think of it, basically, they're basically a water filter that you use in your house. And you basically change the cartridges as you need and as the time comes. So we have a 3x3 system here, and this is the 1 kiloton per day system that we're currently underway with the designing and certification of. So it's a little bit different to the direct air capture, and it's got a much higher capacity, in essence. Next slide, please. So where are we at? What have we done? So I've already explained that we've already demonstrated a 5 ton per year system, and we have our direct air capture units that, in a scaled-up fashion, we should be in a month's time putting out the 0.25 tons per day. And then after that, in about 3 months' time, we should have the 1 ton per day DAC system out and in the field. We have got already a field demonstration site with an angel investor that is providing all of those aspects, as well as looking into the post-combustion capture, looking at building 2 tons. Now, what we're doing there is looking at the chemistry of optimization in regard to SOx and NOx and interactions with that, and building the system that is 1 kiloton and then scaling that up to 4 kilotons. In regard to the commerciality and where we're at, this is majorly where I do a lot of work in. We know what our addressable markets are. We know what regions we're targeting. We know who we're talking to, and we know who our competitors are. And I'm happy to share all of that information if anyone basically seeks to learn more. And that's my contact details there if you wish to get in contact with us. Thank you, Eric.
Hey, thank you very much, Amir. And also for Amir, if you have any questions to Amir, please type them in the Q&A box, and we'll do a Q&A round following the last presentation of this category. For that, we're going to move to Scandinavia, to Benjamin Lorenzen of OceanTeam Scandinavia. Benjamin, over to you.
Thank you, Eric, for that introduction, and thank you for the past presenters for some interesting information already. So I'm gonna be presenting this technology that we are working on and have been working with for the last time here at OceanTeam. This is the CCUS Reactor, carbon capture utilization storage reactor system that we are working on. And maybe I should mention I'm working as a CIO here at OceanTeam Scandinavia. This technology has been built because we can see that there are some important knowledge gaps that we still need to fill out if we are to consider large-scale geological storage of CO2, both now and in the future. And if we want this industry to be as efficient as possible, we need to do heavily research and development within this area. So with this technology, we are able to do different simulations and tests, and specifically we are able to do multi-material screening and also process testing to make sure we are doing everything as efficient as possible. Yes. Yeah. So we just have a few categories here highlighted where we can see that this technology can help enable a more efficient work being done in the future. Yes, next slide. Yeah, so as I mentioned before, we have decided to go into this work because we can see by looking at projections for future emissions that we will most likely still be emitting a lot of CO2 in the future. So we believe that it's very important that we do something actively with all this CO2. So of course we both have to utilize CO2, but also we expect back to the other side again. We also, we expect that that this industry will grow for the next 20-30 years, and we have to be able to support the industry with novel technology and knowledge. Yeah, next slide. Okay, so a little bit about the perspectives on this geological storage of CO2. We already know that we have 100 years of capacity available for on the global scale to this geological storage, and we know that we have to utilize at least some of this capacity. We know that there are already numerous pilot projects around the world, but we still have all of these gaps that we think is important for the industry to grow and be scaled up, going from pilot projects to a full-size industry. Yeah. And we also know that we still have a lot of potential not yet utilized. So we think it's important to be able to support this growing industry. Next slide. Okay, so just a little bit illustration on where we see us going with this technology. So we know that we will to be able to go from present day know-how and technology and reach our future climate targets and do this net zero mission. We know that we will have to ongoingly optimize and focus on risk mitigation, optimization, cost reduction, infrastructure building, and upscaling in general. So what we are presenting here is the small-scale technology along with expert competencies within relevant areas. And by providing this in combination, we will be able to ongoingly support with novel solutions and more efficient solution in general to be able to realize these future climate targets. Yeah. Next slide. Okay, so very short presentation from my side, but then again, we had 5 minutes, so hopefully this was a little insight to what we're doing here. Thank you for the attention.
Yeah, and thank you very much, Benjamin. Indeed, a short presentation from all the 3 companies, but indeed the aim is to give the attendees a brief overview. And if of interest, of course, they can follow up with any one of you for more in-depth discussions. So I do see a couple of questions coming in. And let me first start with a question for carbonate systems. And the question is, can you also extract CO2 from flare gas? And it would in that case be a real and a great breakthrough. Selina, can you shed some light on this?
Sorry, I didn't quite hear the question. Could you repeat it?
The question is, can you also extract CO2 from flare gas?
I will be honest, I will have to double check that with our CTO. And if so, it would likely be in an R&D stage. So I would welcome whoever asked that question to send me an email, and I'll be sure to direct it to the correct person.
Yeah, let me give you also another question then, a question that came in. Does the CO2 enriched product from carbonate systems present different properties than conventional building material, which may limit or improve certain applications?
It's a very good question, and one that I could speak to for quite a while, but I'll try and keep it short. What we do see is that there's actually some advantageous properties. So in terms of where you can actually apply it, it's a lightweight aggregate, so that in itself will obviously have specific applications. But we do meet building standards. Specifically, it's something that we look at, but we do deal with it on a case-by-case basis, and I just want to dwell on that just for 1 second. And the reason being, we use the residues as the carbon sink. So what we specialize in as well is we've tested over 1,000 samples of residue, and that will always vary depending on the industry and the plant that we're working with. So we always make sure that we test that residue to the full capacity with our lab team to make sure that we also meet the standards that each client individually has, depending on application and region.
Thanks for that, Selina. A question to Benjamin. Are you running experiments as well, or is the focus on simulations?
One more time, Eric.
Are you running experiments as well, or is the focus on simulations?
So we're actually running both experiments and simulations. Currently, we are actually part of a larger project which is funded by the UDP here in Denmark, where we are in collaboration with GEOS and DTU and some other interesting stakeholders from the industry, where we do a combination of these things, all to be able to gain more knowledge on material behavior in relation to CO2 handling and storage on long-term scenarios. Yeah.
Yeah, thanks. Hey, a question to Amir. What is the technology readiness level of your technology?
Okay, so currently we're at TRL 5, and hopefully in a short while, with the units getting into the field and being demonstrated for more than 10,000 hours, we're hoping that we will get within a year to about a TRL 7.
Yeah.
Excellent. So our angel investor is actually the biggest sort of sequestration project in Australia, which is planned to have 1 million tons of CO2 sequestered per year.
Okay, that is good information, and hey, good luck with all the preparations for that work. Very exciting. Thank you. And there's actually a question to all three speakers. So, what do you see as being the main challenges currently associated with CCUS commercialization at scale? Selina, would you like to have a go first?
Of course, and I think we could host a webinar on that question in itself. But I'll start off. I think one of the core challenges is also just the speed at which we need to do this. If we need to stand any chance in doing this by 2050, we need a very quick adoption rate. And depending on the industries that we're working with, there might be some hesitance to that. And that's definitely something that we're working with. But we do sense an eagerness for change. And I think that's definitely a positive message that I would also like to share, is we see the willingness. It's just the speed at which we that we will need to dwell on a little bit.
Thanks. Any other thoughts from Benjamin or Amir?
Well, one key critical question, and I think Benjamin sort of highlighted that, if you're going for sequestration, there's a number of different scenarios that you need to take the risk into account, and therefore that technology is really valuable. At the end of the day, what makes investors invest is commerciality. And what we have said, and hopefully that came throughout the presentation, and I do apologize, you went through it a little bit too fast, but we are producing a ton of CO2 at less than $50 a ton, right? That enables us to basically capture most of the marketplaces. And we're actually setting some samples to even get a food and beverage quality certification from the US. So by dropping the cost for capture, it actually enables investors to then look at the different incentives, like the 45Q, like the different incentives that the different governments are coming up with, to basically accelerate the investment into the area, to actually allow for these technologies to be implemented as fast as possible, as was mentioned previously.
Yeah, thanks for that. Any additions to that from you, Benjamin?
Yeah, I agree completely with Selina and Amir on what they said. We need global support from all of our politicians. It has to be their responsibility first of all to make sure that this is commercial. Viable, because it's like the egg and the hen, situation we have going on, and as Selina said as well, we have to do everything fast, and that's also why we have put our technology into this world, because we know that we have to do extensive research and development to be able to optimize everything as much as possible within the short time frame. And all the infrastructure, of course, that has to go along with this. So many different challenges.
Indeed. Yeah. Hey, thanks a lot. And with this, I would like to...
Right? Able to collaborate with other people. That's all. Have that willingness to do it ourselves.
Absolutely. Collaboration is key today. So 15 great presentations. And also thanks to all the attendees, and hopefully you will leave this webinar with many ideas on how you can improve in performance and realize your goals with technology. And we will continue to create visibility for technologies via the platform, technologycatalog.com, such that companies can find and select the right tech to improve performance. So with that, many thanks, and I wish you all a great rest of the day.